Now you're ready to do the calculations, ready to plot your graph. So remember, the graph we want, that we're aiming for, is a single time oscillation against the square root of x. Okay, now the first thing is we might have x in centimetres, and we might have 10t1, 10t2, 10t3 as our repeat readings. And I know there's units and things involved in there as well. So what we're going to need to do firstly is work out the mean of the 10 readings. The next thing we're going to need to do is work out the value of a single time period. So basically from there to there, divide each number by 10. And of course these are going to need their units as well. Now these repeat readings have their plus or minuses and their unit. The mean column doesn't have a plus or minus, just the unit. The uncertainty in the mean is going to be something we're going to calculate a little bit later on. So this would give us our values of t. So notice that we're not plotting 10t, we're not plotting the mean of 10t, we're not plotting the repeats of 10t, we are just plotting effectively the mean divided by 10, the value of 1t. We should have 1, 2, 3, 4, 5, 6 lengths. And we should have 1, 2, 3, 4, 5, 6 times that correspond to them. That's what we need to plot. Okay, so the next thing, of course, we need to plot for the graph would be the root of x. Now, if you've done x in centimetres, the next thing you need to do is do it in metres. Now, if your x had a plus or minus value, the uncertainty, that would be in centimetres. You need to transcribe that to here, but you need to convert it now to metres. So that's easy. You're just basically taking your value in centimetres, let's say 18.5, dividing it by 100, 0.185. Let's say that your uncertainty was plus or minus 0.2, so 2 millimetres basically. Then that might become divided by 100, so 0.002. That's 2 millimetres, but in metres instead. So you've not changed the value, you've just converted the unit, that's all. Make sure that it matches. Now we need, on the graph, remember we are after root x and t, so we're going to need just one more column where we have root x. Now, x is measured in metres, but root x is not. So root x also has a unit of root metres. It doesn't have a plus or minus, however. So don't include the plus or minus. That's a calculated value, so it's going to have a calculated uncertainty that corresponds with it. You can see how this starts getting a little bit big, so feel free, again, to split this up into multiple tables. And a little bit like before, we numbered the columns with a task number. You should have that reference number in these rows too. And so on. Now you've got your values of t and root x, you're ready to plot the graph.